Hi, hope you had a nice Labor Day weekend. We are starting in on Unit 2, which is matter. So this week we're going to be looking at kind of classifying the different categories of matter into element and compound and mixture, and drawing particle diagrams to represent a sample. So let's get started with the definition of matter. And if you remember back to kind of the first week of school, we said that chemistry is defined as the study of matter. And matter now is any sample that has mass and takes up space. And really that includes everything that is tangible in this world. Has mass, that means it has stuff in it, and takes up space. So examples of things that are not matter are maybe more abstract things like ideas, emotions, even energy. Those are not matter, material things that we can touch and grab and observe, yet they still exist. So matter is those samples that have mass and take up space. And we can represent matter using what we call a particle diagram, which we will look more closely at tomorrow. Today we're just going to look at kind of real-world examples of matter and then classify it as element, compound, and mixture. So let's start off with our three classifications: element, compound, mixture. An element is defined as a pure substance made of only one type of atom. And all of our elements that we know of are found on the periodic table. They're represented by an element symbol. So you could make a note there. All of these are found on the periodic table, which we will start using here pretty soon as a reference for many things. But you will find all of the elements on the periodic table, and they will all have an element symbol. Whenever we see element symbols, they will have a capital letter to start the element. So if I have, let's say, gold, gold kind of has a weird element symbol, but it is capital A-U, that's gold. Or helium, capital H-E, helium. So you'll always start with a capital letter. You'll have no more than 2 letters in an element symbol. The second one will be lowercase if there is a second one. An example of an element with just one letter is nitrogen, capital N. Notice it's still a capital letter, but it just has one letter. So those are all element symbols. You could find all of these on the periodic table. A compound is also a pure substance. However, it has a few different elements bonded together. We will talk about what a pure substance is a little bit more tomorrow, but for now, know that elements and compounds are both pure substances, but a compound actually has more than one atom or element bonded together. Okay, so it's made of 2 or more elements bonded together. Compounds will be combined in a set ratio, and they're represented by a chemical formula. So a chemical formula uses our element symbols, but then puts them together in a set ratio. So for example, water, instead of element symbols, we're using chemical formulas for compounds. Okay, so water is made of 2 hydrogens and an oxygen, so its chemical formula is H2O. Salt is sodium chloride, made of 1 sodium element and 1 chlorine element, NaCl. So there are 2 examples of compounds writing out their chemical formulas. Now, mixtures are not pure substances. They are samples made of 2 or more substances. And those can be picked apart kind of by hand or by a different separating technique. But our mixtures are not pure. Okay, so a sample made of two or more substances. It can be separated physically. There are two different types of mixtures. There's homogeneous and heterogeneous. And homo means the same. So if you think about a homogeneous mixture, then it's going to be kind of the same composition throughout. Or sometimes we say that it's a smooth solution. So that's what I'm going to put here, a smooth solution. Kind of like lemonade. Okay, it has multiple ingredients, so that means it's a mixture. But you can't really see them at face value. You would have to maybe evaporate the water or something like that to really separate it out. So a homogeneous is a smooth solution. It's uniform or same throughout with its kind of texture and state of matter. Heterogeneous, on the other hand, mixtures are more like a chunky mixture, if you will. They have different states of matter, easily picked apart. I think of like trash or even cereal. Like you can pick apart the pieces, you see them clearly. Salad. Those are kind of the mixtures that you would think of off the top of your head. Those are called heterogeneous mixtures. Okay, so there's our different types of mixtures. Now let's look at some examples. So it says use the matter flow chart to classify the samples, circle pure substances, box the mixtures, underline the elements, and highlight the compounds. Let's take a look at this flow chart before we start. Okay. And let's just look at it. It's a quick overview of what we just talked about in our notes, and then we're going to use it to classify our examples. So again, matter is any sample that has mass and takes up space. Ask yourself these questions and go through the flow chart. Can it be separated physically? Meaning, can I pick it apart or maybe filter it or distill it, evaporate water, use a magnet, use a funnel? Can I do any of these things to separate it? If yes, then you have a mixture. If no, then you have a pure substance. Mixtures can be separated using properties like magnetism, solubility, boiling point, and all of those types of things. They also have different types of particles in their particle diagrams. So, next question to ask yourself, is it chunky? Are there multiple states of matter? If yes, it's a heterogeneous mixture made of multiple great ingredients that are easily picked apart, like salad or trash. If not, then it's a homogeneous mixture made of multiple ingredients in a smooth solution, like lemonade or ketchup. So those are mixtures. On the other side, if we answered no to it being separated physically, that means we have to have a reaction, actually, to separate it. It's a substance that has identical particles and cannot be separated without a reaction. So the next question we ask, are there multiple types of atoms? Remember we said that you can have compound or element as pure substances. If there are multiple atom types, yes, it's a compound. Then you have multiple atoms bonded together of different type written in a chemical formula. And we showed water and salt. There are a couple of particle diagrams here to kind of help you visualize what that might look like. 2 hydrogens and an oxygen over here on the left, or a sodium and a chlorine, 2 atoms for the other compound. An element, if it does not have multiple types of atoms, it's just a single type of atom, even if more than one are bonded together, and they're all found on the periodic table. There is a special type of element. They're kind of like element twins. These are called diatomic elements, and you might see them kind of paired up. It sort of looks like a 2-part snowman, if you will. That's called a diatomic element, and there are 7 that exist this way in nature, and they are listed here for you. That will come in handy next semester, so just kind of start remembering these 7 are diatomic, meaning they always come in kind of that twin form. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Those 7. Eventually, you will need to have those memorized, but I'll give you some mnemonics and things like that to help us remember them. As for now, just get familiar with them. Okay, so let's go here, back to our example, and identify what was asked. So it says, classify the samples, circle pure substances, box mixtures, underline elements, and highlight compounds. Let's start by circling the pure substances. So we're looking for things that are elements and compounds. Remember that elements have element symbols, compounds have chemical formulas. That will be a big clue for these. So circling elements and compounds, I see carbon. Yep, that is pure. Neon, also pure. Lemonade, nope. So let's go ahead and do that too. Box the mixtures. We talked about lemonade. If it has multiple ingredients, it's a mixture. Candy bowl, that's multiple things, multiple ingredients. Baking soda, compound. Notice its chemical formula here. Nail polish remover also has a chemical formula. Ammonia, pure substance. Gold, pure substance. Pizza, multiple ingredients. Okay, so that's pure substance mixture. Ask yourself, does it have an element symbol or a chemical formula? If yes, pure. Does it have multiple ingredients? If yes, mixture. Okay, next we need to go back through our pure substances and underline the elements and highlight the compounds. So easiest way to do this, underline anything with element symbol. Carbon, neon, baking soda, that's a formula, formula, here's an element. Okay, so all the ones that had formulas, now you can go back and highlight them because those are your compounds. Okay, so go through, you'll highlight baking soda, nail polish, and ammonia. That is our stuff for today in terms of notes. So you will go through and do that same process with the real world matchup. However, now it's asking you to also separate homogeneous and heterogeneous. So you have element, compound, homogeneous, heterogeneous. Look at the flow chart if you need a little reminder of the difference between the two. And you'll just do that for each one, writing your answer on the lines. The other part of your work today is a computer interactive. You have a couple of games and then apply it problems like we normally see. So that is your work for today.